chemical structure we have found on the basis of Lewis theory, Lewis octet theory, it was all of them were found to be two-dimensional in nature. Okay, like we have written carbon dioxide. Carbon dioxide, how did you write? We have written it like this. This is carbon, this is oxygen, like so is linear. Then when you go for BF3, how did you write? Boron, no, don't write. Boron. It was planar. When you come for CH4, in CH4, what? How did you write? We have written the structure. We have written like this. Okay. So this was also found to be two-dimensional. When you have gone for PCl5, all the structure you have drawn. PCl5. So this was the fluorine. I'm not putting the lone pair. This was PCl5. When you've gone for SF6, so this is the structure. See, we know if so many atoms surrounds a central atom, there will be always a lack of space or repulsion will be there. So that we call it steric hindrance. So this type of structure actually does not exist. Okay, so Lewis octet theory does not give us the true structure of a chemical molecule. Because whenever the formation of a chemical compound takes place, we know it happens by or through joining of the atoms through chemical bonds. And these electrons come from the valence shell of the atoms. But in valence shell of the atom, not only one electron is present, more than one electrons are present. All right, some cases may have been 2, some are 3, 4, 5, 6, 7, like that. So all the cases and all the electrons present in the valence shell may not participate in bonding. So in the formation of a chemical molecule or chemical compound, you will find it results into formation of two types of electron after the formation of molecule. Some electron has taken part in the chemical bonding. We call them as bond pair. And some electrons do not participate in chemical bonding. We call them as lone pair. So you have to take into account the spaces occupied by this electron in the space. Okay, whether they have taken part in bonding or they do not take part in bonding, that has to be taken care of. Because we know electrons reside in orbitals, and every orbitals have a fixed shape. The size of the orbitals containing single electron and sizes of the electrons containing the pair of electrons are different. All right. So on the basis of that, the structural elucidation of different chemical molecules is done on the basis of this theory. See here. Look. Suppose a molecule A has formed bond with B. So in this case, we know that this has given one electron and this has given one electron. So in this case, these electrons are being pulled by both the nuclei. So it will become little stretched. So it will be like this. Why central part is swollen? Because the density of electron is more here. But this, if this atom has, because now it should be octet, so out of this electron present in the shell, only one has taken part. So it has become 2. Then there should be 6 more electrons. So these 6 more electrons did not take part in bending, which you call them as lone pair. So please remember, the spaces occupied by lone pairs are larger. See, number of electrons is same. But as these electrons are only being attracted by A, so this occupies more space. See, that experiment you can do at home. Now the festival is coming. Okay, you'll find so many people are selling balloon on the street. Balloon is like this. This is the balloon. Air is there. So buy 2 balloons. One you hold it in your one hand, and second, same size of balloon. You take it. Then you hold this one by your hand and this one by your other hand and pull it. You'll find in that case the middle portion of this is now it has tapered. It has become small because it is being pulled. Total volume may be same, but the central part is as squished. All right. So in that case, you'll find. So if this is lone pair, then this is bond pair. But amount of air present them in both the cases is same. So this occupies larger space. So in this case, if these lone pairs are present, you will find as they will be closer to each other, there will be severe repulsion. Why there will be severe repulsion? Because electrons, all the electrons, irrespective whether they are bond pair or lone pair, they are negatively charged. And we know like charges repel. So this entire theory is based on the repulsion theory. All right. Now, where you are going to have the maximum repulsion? See, the maximum repulsion occurs between these 2 lone pairs. So you will have maximum repulsion you are going to have between 2 lone pairs. So right now here, lone pair, sorry. Lone pair, repulsion. Then this is greater than, see here, size is a little smaller. So this is greater than lone pair, bond pair, repulsion. And minimum will be the bond pair repulsion. So to avoid repulsion, what it wants to do? It wants to remain far away from each other. If the electrons remain far away from each other, then the repulsion is minimum. See, this you don't require any sense of chemistry. You know, there are some persons whom you like and some person you don't like. The persons whom you don't like, you always try to maintain a safe distance from that person so that he or she should not be visible to you. And even if they are visible or near your vicinity, then you try to move away from that place. All right. So now see. See here. In this case, this is the point. And how much space is around this one? Space is 360. 360 degrees. Clear? Now, if you have taken any molecule like AB, see AB, it has to be linear. It has to be linear. Why? Because we know what is the distance between 2 points. Is always a straight line. Minimum distance between two is straight line. Okay. So now here, right here, yes, now suppose you have taken AB2. AB2. A is 2B are connected to A. So because of that, we call this to be central atom. Here there is no central atom. Here is the central atom. So in that case, if you want to maintain maximum distance, what we'll do? So we'll do 360 divided by 2. So what will be this? 180 degrees. So in that case, you'll find it is A. So this is also linear. So linear. So in that case, you'll find VSCPR concept does not start. It starts from here. So this is only information which I will give. Now if I go for AB3, so what I'll do now? 360 degree divided by 3. It is 120. So how to look like now? See, it will be A, B, okay. So how does it look like? See, it is two-dimensional. This is one-dimensional. Linear is one-dimensional. This is two-dimensional. So if I connect it, how does it look like? It looks like a triangle only. And this is in the as if yes, because it is two-dimensional, so it will be in the form of plane. So what will be the name of the structure? The name of the structure will be trigonal plane. Okay, so I'm going to write. This is very interesting. So I'll write now here molecular formula. Then what we'll write now here? What I'll write now here? Bond. So molecular formula is AB2. Oh. Shape na. Then all with the name and the volume. So how to look like? It will look like this. What is the name? We call it linear, or sometimes we call it cylindrical. What's the bond angle? 180 degrees. 180 degrees. Then AB3. Okay. Here we did not consider any lone pair. Molecules without lone pair on central atom. What is central atom? A. So here in this case, you will find it is B. Okay. In this case, what is the name? Trigonal. What is the bond angle here? 120. Okay, now we'll go for AB4. Don't write. Try to understand. AB4. So, just like that, I will divide 360 by 4. It comes to 90. This is a structure should be A, B, B, B. What is the bonding here? 92. See, is getting closer. Once it's getting closer, 90 and below, repulsion starts. All right? So this is 2-dimensional. All right. Now, see, suppose in your house, your father has made a house, and in that case, everybody is being given one room. So by this way, it continues. Later on, you will find that many of your brother and sister will get married, and after that, they're having children. Then what is going to happen? In that case, there will be lack of space there. So in that case, you will find to accommodate all of them, your father will make the next story above that building. Initially, it was on the ground floor. Now you are having 2 stories. All right? Or you may have 3 stories building. So in that case, everybody can have enough space to move. So this is 2-dimensional. Now, it was thought when it is 2-dimensional, the repulsion is there. So they thought that let us go for making a 3-dimensional one. 3-dimensional. Okay? So moment it becomes 3-dimensional, we find the bond angle has become 109.5 degrees. See, it is 90 and it's 109.5 degrees. You can almost think it's 110. So difference of 20 degrees there. So that reduces the strain between them, repulsion between them. Now, if I add this one, all the edges, if I connect all the edges, how does it look like? You find it looks like we call this to be tetrahedral. All right, it becomes tetrahedral. So this is not correct. This is correct. What is the bond angle here? 109.5 degree. All right. So we'll remove this. All right. Now let us now know examples. Examples. What will be the example here? BCl2. What is the example here? Carbon dioxide. What is the example here? Carbon dioxide. In this case, what is the example here? BF3, BCl3, AlCl3, nitrate. All right. Okay. Now I will not use nitrate now here. Nitrate. Oh, nitrate I don't use. Then sulfur dioxide. These are the examples. Now, in case of this, what I can write? It is CH4. Okay. Then NH4 plus, pH4 plus, like this. So draw. After that, I'll do that next. A, B, 5. In A, B, 5, you'll find in A, B, 5, here, please see. This is not difficult. AB4 was this. This was AB4. I want to add one more. So what I'll do? I'll connect B from below. Moment the B4 from below will come, there will be repulsion between this one with this, this, and this. How to avoid repulsion? It was like this now. It will become now straight. So in that case, when this goes up, how do you you go up and you will get this. Like, okay, very interesting. You know, these molecules are, these structures are being given theoretically initially, and later on you found that they exactly matched. This is planar. Okay. Like this. That is, see, this on the top, it is like this. It is like this. Okay? And this is from below, like this. Okay? These are called, name is Trigonal Pyramidal. Trigonal pyramidal. See, you've heard of the pyramid. Pyramids. Now, pyramids are of two types. How the shape of pyramid is being decided? By the shape of base. Okay? Shape of base. So, shape of. So, base can be triangular. And base can be square. All right. So, if it is a pyramid like this, so this is called trigonal pyramid. And it can be like this also. Many of the pyramids that you have seen in a picture, okay? So it is square. Okay? So both type of pyramids are there. This is square and it is triangle. Triangle. All right. So on the triangle, this same shape you'll get in physics laboratory, which you call it prism. So prisms are trigonal pyramid. So one trigonal pyramid is on the top and other is at the bottom. Because of that, we call it trigonal pyramid. Now see, very interesting thing here. What is the interesting thing? from AB to bond angle is 180 degree. AB3 bond angle is 120 degree. In AB4 it is tetrahedral. Oh, AB4 shape you write tetrahedral. I forgot to write. AB4 shape is tetrahedral. Sorry, name is tetrahedral. Then in tetrahedral, the bond angle is 109.5 degree. But in this case, you will find there are two types of bond angle here. Look, in the middle, the plane, the bond angle is 120 degree. Okay, but these are all 90 degree. So you have two types of bond angle. 120 degree along the plane and 90 degree along the trigonal bipyramidal. It has two types of bond angle. If it's along the plane, it's 120 degree. Along the axis, it is 90 degree. Example, BCl5. BCl5. AS. Phosphorus pentachloride, phosphorus pentafluoride, arsenic pentafluoride. Then we have AB6. In AB6, now I cannot add along the axis. So I have to add along the plane. So if I add it along the plane, how would it look like? See. This is the plane. Look, this plane is now square. This is along the axis. All right. See. So here also you have a pyramid, but this pyramid is now square. Okay. So it is like this. See here. It is like square. Four of them are square. And from below also you have. So we should have called it square bipyramidal. But in geometry, for square bipyramidal, already one structure is known. It's called octahedral. Octahedral. It's called octahedral. All right. What is bond angle here? All of them are, say, it is 90, this is also 90. It is only one type of bond angle. It is 90 degree. Example is SF6. Okay. Then SCF6, SECl6. Again, let me tell you. Summary. AB2 linear. AB3 trigonal. AB4 octahedral. AB5 trigonal by pyramidal and AB6 is octahedral. Being given in your book. Up to this much is given in your book. Then I'm going to write one more for you. AB7. Only one molecule is there. AB7. Only one molecule without long term. See, any extra atom that you are going to add, you have to do add now in the plane, not on the axis. You can only have two. So it will be when it was AB6, I put 4 on the plane and 2 on the axis. Now here what I have to do? I have to put in the plane. Here. B, B, B. I'll draw axis little longer. B, B, B. I'll join the plane. When I join a plane, I get a pentagon. Pentagon. So in that case, name is pentagonal by pyramidal. Here, what is the bond angle along the plane? No problem. You divide 360 degree because around this A, 360 degree is there. Divided by 5, how much it comes? Huh? See, it is 7 and it is 2. So along the plane, angle is 72 degree and along the axis it is 90 degree. So right now here 72 degree along the plane and 90 degree along the axis. Only one molecule is there. So this is important for your entrance exam. IF7. Iodine heptafluoride. Iodine heptafluoride. This is not given in your book. I'll show you how to draw this structure. Suppose you are being asked to draw the structure of BeCl2. So what you will do now? First you write valence shell electrons of Be. Boron atomic number is 4. So this beryllium is 4. So 1s2, 2s2. This is the last shell is called valence shell. Okay. So how many are there? 2. Okay. Now it is Cl2. So how many bond do you have? See here. Bond will have 2 only. All right. So each bond is, see, it will be like the B, Cl, Cl. So this is one bond pair. And this is another bond pair. So how many bond pair you have? You have 2 bond pairs. So number of bond pairs. It is 2. That is, you do not have any other electron to form bond. So what will be the model of the molecule? Model of the molecule is AB2. Now we are already given in the tabular form. What will be the shape? What will be the shape of the molecule? It is linear. What will be the structure? Structure is the structure of BCl. Okay. What is the bond angle here? Bond angle is 180 degree. Okay. So this one you write on the top, then you write this, then this is the one.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Full, na? Okay. Now we'll go for BF3. See, what is the atomic number of boron? 5. 1s2, 2s2, 2p1. This is the valence shell. So how many electrons are there? 3 electrons are there. So each electron of boron combined with 1 electron of fluorine to form 3 bond pairs. How many bond pairs are there now? Okay. What is the bond pair? Bond pair is 3. So we'll write here now. Number of valence electron is 3. Number of bond pair is 3. What will be the structure? Model of the molecule? AB3. What will be the shape of the molecule? Trigonal planar. What will be the structure now? B F F. What is the bond angle here? 120 degree. The bond angle is 100 degree. Then CH4. Earlier by mistake I written BF. I should do BF3. Huh? Correct it. CH4. So carbon is 6. 1s2, 2s2, 2p2. Right? Okay. So how many bond pairs will have? See, 4 electrons. So carbon, each carbon will, carbon will give you 1 electrons to each of the 4 hydrogens. So how many bond pairs will have? Will be 4. So now you have 4. Will be 4. Will be 4. And what will be the structure? Tetrahedron. So how it will look like? It will C H H H and H. All right. So this. And what is the bond angle here? 109.5 degree. The bond angle is the structure. Bond angle is 109.5 degree.
Sir, excuse me, sir.
Yes.
In that one, valence shell
Valence shell electron. The last shell is called valence shell. So how many electrons is there? 2 plus 2, 4.
No, not that, sir.
Which one?
That one, valence shell electrons of, that should be carbon.
Oh, yes, carbon. I did not change. Na? Earlier should be boron, carbon. PCl 5. Phosphorus atomic number is 15. 1s2, 2s2, 2p6, 3s2, 3p3. This is the valence shell. So 5 electron will make 5 bond pairs. Okay, so is 5. So we'll write here number of valence electron is 5. Bond pair 5. Model of the molecule is AB5. Shape of the molecule now you know it is trigonal pyramidal. So what will be the structure? Structure I think will do much better, draw much better than me. See, this is this. This is the axis. Okay. This is Cl, Cl, Cl. This is Cl and this is Cl. This is the one. All right. Bond angle is 120 degree. And this bond angle is 90 degree. This is called axial along the x. This is called axial. Okay. See, look, this is Earth. This is called equator. And this is called axis. So this is axial angle. And this is called equatorial. So it has two types of angle. So what we'll write now here? Bond angles. Axial 120 S 90 degree and equatorial is 120 degree. See, this is the interesting thing that people have first drawn it theoretically without knowing the molecule. When the molecules are being made, they have found is exactly matching with this. তারটা তো গুড্ডু ফেলে দিয়েছে তারটা তুমি ভালো করছো না রাখি কোনটা ওই যে স্টিয়ারিং এ ওই বাদ ফলে বিষয় তো ভালো কিছু Okay. Then SF6. Sulfur is 16. 1s2, 2s2, 2p6. Then 3s2, 3p4. 2 plus 2 is valential. How many electrons are there? 6. How many bond pairs will be? 6. So this is for sulfur. 6. 6. Model is what? AB6. Shape of the molecule octahedral. How would it look like? Sulfur F F F F. This. So this is octahedral shape. Okay. Let us, when you give a three-dimensional approach, then you know it is octahedral. This is only one type of bond angle. All are 90 degrees. So bond angle is 90 degree. Very good. No. F7. See, halogen has 7 electrons in its valence shell. Okay. All halogen has 7 electrons in its valence shell. All. So in case of iodine, 7. 7 electrons are there, 7 fluorines are there. Bond pairs 7. Model of the atom is AB7. Shape of the molecule, I told you what is that? Pentagonal bipyramidal. This is not given in your book. So this is iodine. This is the axis. F. One side there will be 3 and other side there will be 2. So I'll join it. Okay, this. So this is, what is the bond angle? Here also you'll have axial and equatorial bond angle. Bond angles. We'll find now here axial 90 degree. Because it's perpendicular to the plane like this, 90 degree. And equatorial 72 degree. Of halogen always contains 7 electrons. This much you should remember.
So done. See,
you will find in every institute there are some specific chair for some specific persons. In your school, your principal has a chair. All right. Nobody goes and sits in this chair. If principal is present, he will sit there. And if he is not there, that chair will be kept empty. If the chair is kept empty, person is not there. But is it not the space is being occupied by the chair? Huh? So lone pair is like this. So if I go for a molecule AB3, all right? If one of the B is missing, then I'll write here AB2. But the space for that molecule will be there. This B is not there, but the space is there. So I'll just tell you, suppose, see, in our house, we have so many things are there, na? So in your house, we can have a pet dog, pet cat, okay? And suppose you find that there are in Middle East, there are some rich people are there, they are even keeping pet tiger also, right? But we cannot afford to have it. But there is no harm if I have a pet ghost. Huh? Say, so don't take in other way. Say in our houses, we know we get maximum affection from our grandparents. So if your grandfather or grandmother has expired, but in your memory always it is he or she is there. All right. So in such case, some specific space is there. Suppose the chair where he or she is to sit, the bed where he or she is to sit. We always feel that he is present there only. So in that case, the B is missing, but the space is there is always for B. All right. So I can have a molecule where B is not there, but a pair of electrons is there. So you have to respect its place. All right. Huh? So whenever a lone pair is there, you assume B is there. So generally what you do for lone pair, we use the symbol F. In your book, it is written as E. E means electron pair. All right. So look here. A, B to E. A, B to E. Immediately we will compare that in place of B, E was in place of E, actually B was there, but now it is not there. So it is not equivalent to AB3. In your book, they have not done like this. I'm just tell you the simplest technique to remember. Okay? So it is molecular formula. So if it is AB3, what should have been the shape? What should have been the shape? Huh? The shape we know. It is trigonal planar. How it should look like? It should look like this. I should have put E, but actually B is not there. So who is occupying this space? This being occupied by the space, this is the electron pair, which is known as electron pair or lone pair. Actually, it should have been written lone pair, but in your book they have written electron pair. So I have to write here electron pair or lone pair. Oh. electron pair or lone pair. So suppose this is you. Okay. And this is your brother. And you always feel that one of your relative or someone is there, but who is no longer there. So this is the one. Okay. If you have taken a photograph, will it appear in the photograph? This person will not be there. But you feel in heart that he is always with me. Just like that, always you feel that God is with you. But you have not seen God. We might have seen the picture, but nobody has seen God. All right. So the people imagine that this is the appearance of this God or that God. Okay. So in that case, we respect the space, but this is not there. Now, how does it look like? Can I say it is trigonal planar? Because I cannot see. Atom is not there. Electrons are not visible. Atoms are visible. In X-ray, you can observe the presence of atoms, but electron pair is not visible. So in that case, how does it look like? So shape is, here the shape is band. Shape is band. Or what do we call it? Or V-shaped. Or you call it V-shaped. All right. So always you compare with that, because we are being given we are being given 6 models. What are those? AB2, AB3, AB4, AB5, AB6, and AB7. Why I did not take AB2? Why I did not take AB2? Because we know if you remove one of the B by an electron pair, it will be, see, in AB2, it was this. In AB, E, this is also linear and this is also linear. So because of that, we did not consider ABE. So it is bent. Try to understand a little carefully. Example I'll do. Example is sulfur dioxide. So what is the valence shell electron? Now we know valence shell electrons of sulfur is 6. Now just now we have done. See here. In case of oxygen is at a number of valence shell is 6. We know after formation of bond, always it becomes 8. How many electrons it will take? 2. Then it will become 8. So in that case, number of bond pairs, This is the important demerit of VSEPR, that VSEPR could not distinguish between single bond and double bond. They consider all of them to be single bond. So how many bond pairs are there? How many oxygens are there? 2. So right now your bond pair is 2. But actually between 2 oxygen, 2 double bonds are there. But we have to consider as 1. All right. Now see. Now In this case, sulfur has given 2 plus 2, 4 electrons. But total number of electrons is what? 6. 6 minus 2 is 2. So how many lone pairs? What is the meaning of pair? Pair means 2. Okay. So here will come here number of lone pairs. It is 1. See here. So this is the electron which did not take part in building. 1. So what is the model? Model is AB to T. Now that you will not write in your copy, in your school copy, but in your here you copy. In your copy you will write equivalent to what? What is the original model? Original model is this. Equivalent to AB3. Now you know that if it is AB3, it should be trigonal planar, but one of the B will be missing. Okay. So in that case, what I'll write now here? What is the shape? Shape is bent or V-shaped. How it will look like? You write like this, this, and this is the. Okay, we'll do. Take today. It is going to take a lot of time. Okay, then bye for today.
Bye, sir. Thank you, sir.
Welcome, welcome.
Bye, sir.
Bye.